Good morning. My name is Greg Wadley. I'm with CTC and Associates. I'm the Clear Roads Administrator. We're here for the final webinar for the project entitled Evaluation of Direct Liquid Application of Salt Brine versus Granular Salt as Measured Through Various Performance and Safety Metrics. This research effort was led by the research team at the University of Wisconsin-Madison. The webinar is being recorded and it'll be posted on the Clear Roads website later this week or early next week for viewing by you or your colleagues at your own convenience. We also ask that unless you're speaking, please remain off camera and keep your microphone on mute. However, if you have any comments or questions, please don't hesitate to enter them into the chat box and we'll address them at the end of the presentation. Except for the part where I think Andy was talking about getting feedback on the infographic. I think that's everything I need to say, so I'm going to turn it over to you, Andy.
Sounds good. Hopefully everybody can see my screen okay. Looks like it. Okay. Hi, everybody. I do apologize. I've been recovering from the flu, so if I start coughing a little bit, I'll try to mute myself. I have some cough drops and water next to me here. So welcome, everybody. Thank you for taking time out of your schedule in this very wintry time that we have, even though we're not officially in winter yet, but it sure does seem like it outside here in Wisconsin. My name is Andy Bill. I'm the Associate Director of the Traffic Operations and Safety Laboratory. The wonderful team that helped us worked on all this together. We have Dr. Boris Claros, Dr. Madhav Chituri, Wilf Nixon, and David Noyce that are all on part of this. Madhav and Boris and Wilf are all on this call. So if there's questions, as you guys have, feel free again, as Greg mentioned, put them in the chat. We can address them as we go, or folks can, the team can kind of look at those and address them too in that chat part. We're here to discuss the project that we did on the evaluation of direct liquid application of salt brine versus granule salt as measured through various performance and safety metrics. So as we think about this, we know that there's an increasing implementation of salt brine. I think a lot of you guys on this call are probably already thinking about how much salt brine that you're using in your own jurisdiction. As we think about our winter maintenance performance measures, we usually kind of think about, time to bare wet is the most commonly used, but we also think about our materials used. What is the ice melting capacity, more in that laboratory setup, our vehicular speed, and then kind of moving into this pavement friction and grip that goes along with it. Through our previous research, we know that salt brine compared to solid salt reduces the amount of salt used by about 24%, reduced the time to bare wet by about 15%, and resulted in about 8% higher pavement friction. So this was salt brine compared to solid salt on that side. We know that as we think about this, these are kind of mostly laboratory experiments that have done in the past. There have been some field-based studies, but it was limited. And then kind of determining the operational and safety performance, so that salt brine direct liquid application DLA. We wanted to assess the impact of storms and treatments on the road conditions over a specific amount of time. Storms don't all just come at once, they go over a period of time, and so do our treatments. And so looking at those through that time process and are looking at it. So we had two parts where we compared salt brine DLA with solid salt. The first part was a literature review and agency survey. Thank you for those of you guys who are on the call that participated in our survey. Our research cannot be done without you guys and participating. So we collected and synthesized information about differences of chemical materials, performance and safety metrics that are currently being used. Part two was a field data collection and evaluation. This built on part one. So we have the information that we're looking for. We want to go ahead and then conduct the field testing and compare the performance of salt brine with granule salt. So these are the tasks of those parts that we talked about. So task one, lit review. Task two, survey of practice. For our part two, our task three was our field testing protocol. Collecting the data, analyzing the data, and then the final deliverables, which this webinar is part of. So we had our Clear Roads Technical Advisory Committee approved us moving forward with part two and helped us throughout the process. Much gratitude to our Technical Advisory Committee for meeting with us throughout this project. So I'm going to take some time and go through our task one, our literature review, looking at winter storm impact, performance measures, and previous survey of practice. So as we think about this, we looked at our vehicle speed and recovery times. We wanted to capture that, traffic volume and capacity, traffic delay, pavement friction, any crashes that were kind of looked at through those winter storms, and then weather and roadway conditions, and then previous surveyor practice. So we kind of had all of those in our groups and are looking at those and spending some time to kind of think about all of the literature that goes into each one of those topic headings and are looking at it. Our survey of practice, we did a survey design, distribution, and questions and responses. We had a geographical distribution of responses by state here. So the bluish color that you can kind of see, bluish green color, is who responded. The numbers within those states is how many agencies responded from in there. So we had 28 responses from state agencies. We had 1 international response from Denmark. 1 response was a undetermined location in the United States. So you can see most of them had 1 response for the states, but a couple of the states we had more than that: Minnesota, Kansas, Wisconsin, and some others on that. We asked, are you willing to share your data? Kind of thinking about that on that response. So, what data are you collecting? Are you willing to share it? We had 16 responses that said yes, 10 that said maybe, and we didn't have any that said no. So that was a good start to that process. The key findings is the most common use of salt brine direct liquid applications on the anti-icing. As we think about de-icing, thinking about DLA, pre-wet salt, solid salt applications, and then the shake and bake is a little less common. From an experience standpoint, kind of the most experience was on the pre-wet salt. DLA is, while it's definitely becoming more of a practice, it's kind of relatively less experience still at this point in time compared to that pre-wet salt. We asked questions with regards to how do you look at your performance now? How do you measure it? 60% of the response looked at quantity of materials. 53% looked at that time to bare wet. 43% looked at travel speed, and 47% looked at level of service. When we asked the question with regards to what is the technology and methods that you're using to do these performance metrics and looking at it, 83% said visual inspection, 47% used some sort of GPS AVL side of things. 20% have kind of this non-contact friction devices that we'll look a little more closely at later on. From the metrics monitored standpoint, we have 70% that looked at kind of that measuring that roadway condition. What are we seeing out there? 57% level of service, 50% traffic flow and speed, 50% safety, and 50% amount of materials used. And then this gets back to our kind of willingness to provide some of that data and looking at through that survey. As we moved on to task 3, this was kind of looking at our field testing protocol. What are the methods that we're going to look at? Looking at our study and control routes, which I'll give a little bit more in depth, and then looking at the road weather information system and the AVL data on that, RWIS and AVL. So our methods, we did 2 that we looked at. So there's a study and control route comparison. This is going to be looking at a divided roadway. So one side, so it's under the same conditions. We're going to do salt brine in one direction and then solid salt in the other direction. We use the AVL data. We also collected friction measurements, vehicle travel speeds, and other performance measures for this comparison. The other method that we looked at was the RWIS station data. We gathered friction data, AVL data, and looking at a time series for that RWIS, which I'll talk a little bit more about as we get into the data side of it. So here's our required and desired data. I think all of you guys that have worked with researchers know that we always want all of the data that we can get, but we understand that there's limited time and limited situations. So we have our required side and then our desired side of looking at it. So our required is our route information. What is the start and the end routes? This will be done just one time. What is the ADT, number of lanes, functional classification? This just kind of gets us started on it. For the treatment, this is going to be done every storm. So our required for this is whether it was anti-icing or de-icing, the materials used on that. And then our desired was amount used and application rate, frequency of application, and that GPS AVL. For each storm, we wanted to think about when is that storm end, start and end time with it. And then if we can, that pavement temperature at 60-minute intervals or range for every storm, air temperature, type of precipitation, and precipitation amount with that. The required for this was the start and end time and the pavement temperature. Then we had some desired as well for the rest of them.
Dude, what?
All right, thanks for that. In terms of performance measures, we looked at time to bare wet. We got that for every storm. And then our desired were the rest of them here. So travel time and speed, every 15 to 60-minute intervals for every storm, and the normal condition as well. So we can compare it against something. Traffic volume, friction values, road condition ratings, and then crashes within that. So looking at the storm and then also during those normal conditions. So we used the survey of practice, and we kind of reached out to those folks that said interested in kind of maybe sharing that data and working with us. We also looked out to agencies with known application of salt brine. And then we looked at, our Clear Roads project manager really helped with our outreach effort on being able to do this. These are our list of contacts that we went through and being able to look at it. So we used our West Station data from Wisconsin DOT and Iowa DOT. And then we did 2 studying control route data that I'll go more in depth with Jefferson County and Sheboygan County here in Wisconsin. So I'm going to go through the field data collection. We're going to be talking about our studying control routes, what those look like, and then looking at our ROS sites with it. So as mentioned already, our studying control routes were in Jefferson County and Sheboygan County. The materials that we used were salt brine DLA on one side and solid salt on the other. And our performance measures were application rate, vehicle speed, friction, and time to bare wet. This was our Route 1 here in Jefferson County. It's the Rock County line to Old 26 Bridge. There, it's about 3 miles long. You can see it kind of in the bottom right-hand side. That's our map for that 3.3 miles. You can see the start and the end through that on that side. It is a 1 truck capacity. Brine is 800 gallons. The solid salt's 14 to 16 tons. You can see in the picture, kind of in that red kind of call out box a little bit, is where we had solid salt on the black side, and then on the pink side is our salt brine. So again, under same conditions, one side of that divided highway is looking at putting down solid salt, and the other salt brine. For our data collection, we use the Marwis friction device. The data is auto-uploaded to View Armando via cellular connection, and we had 5 storms that we looked at on this route. Excuse me. For our Route 2 in Sheboygan County, this was located on State Trunk Highway 23 between County Road P and County Road O. It's approximately 3 miles long again. This is able to have a patrol vehicle. This time was equipped with a Marwis friction device, and data was automatically uploaded as well to the same side. For this site, we collected information for 6 storms. So you can again see the map there on looking at it. And then in the bottom, you can see our solid salt is on the top of our picture here, and the salt brine on the bottom of the picture, and being able to look at that. So for these routes, we had an online storm reporting data. Again, thanks to everyone that's able to help us. I know that data collection is a hard part. We can't do any of this work without you guys to be able to look at this data and being able to look at it. So the online storm report data has the information here. So it's basically the storm start and end times, the dates, the type of precipitation, what was the accumulation in inches, any roadway surface conditions, pavement temperature. They had a 23% sodium chloride brine in gallons, how much was put down. What was that salt brine application rate, gallons per lane mile? What was a solid salt dry in tons? If there was a solid salt pre-wetted in tons, what was that? Any pre-wet agent? Solid salt application rates, application frequency. When was the time to bare wet accomplished? And any comments or file uploads. We did want to look for crash data. Lucky for us, there was none during that data collection on that side of it, so there was no crash data at this point to look at. So Good from a safety perspective, a little harder when we're looking at some of this other work, but I'm glad from a safety perspective that we didn't have any during the data collection. Here is the MARWIS system. This is an advanced road weather information sensor. It looks at it. It is put onto the back of a vehicle, a patrol car, or a truck, depending on what it looks like with it. There's pictures on there on the right. It's able to do temperature and humidity sensors, status LED, your connection plug, your pyrometer, 4 transmitters and 2 receivers, and kind of how that all works on that side. This is able to give us a equivalent friction value, and are looking at it. Obviously, we're not doing a skid test on this roadway. We're doing it through these information sensors with it, but it's able to, at least we're able to compare relatively to against each other on this to be able to look at that. So as we moved into our RWIS stations, Iowa DOT, we had the 2019 to 2023 winners. We're able to look at those. These are the 3. We have RWIS 24 in Iowa City, I-80, RWIS 5 in the city of Ankeny, and I-35, RWIS 71 in the city of Grimes, and Iowa 415. For Wisconsin DOT, we had the 2024-2025 winner. We had 4 of those here that are listed. So the village of Hortonville, State Trunk Highway 15 at County Highway JJ, City of Appleton, I-41 at State Trunk Highway 441 southbound, Town of Tipler, State Trunk Highway 70 at State Trunk Highway 139, and the City of Green Bay, I-43 at the Leo Frigo Bridge. So here you can kind of see here, this is Ankeny, and looking at it on the Monarch Highway. You can see the picturing and the kind of call out box from the overhead Google Maps on that side. So this is northbound of I-35 at Northeast 36th Street, 2 lanes in each direction with a median separated. And we had 4 storms that we looked at for this location and are examining it, which we'll talk more about on the data side. In Neenah here, we're able to look at this. This is westbound US 10. 2 lanes in each direction, median separated again. This had 4 storms as well. So you can see the location right next to the bridge on this side and being able to look at that. So as we think about the information here on the RWIS stations, want to really kind of highlight the date, time, the friction, the ice percent, and the surface temperature. Those are the kind of the major ones that we used and looked at with it, but all the other data associated with it. Hopefully, as you guys are thinking about this and are looking at maybe from your area, hopefully you're getting some information about how you can use this. But if you have some of these opportunities to look at the data as well through your RWIS stations, hopefully this helps with it. With our routes and RWIS AVL data, looking at the timestamps, the location, material speed, direction, trip timeline. You can see a lot going on here in a couple different pictures here. So the picture on the top right is from a dash cam. You're able to see the kind of the location of it and what they're seeing out the top. On the bottom there, you're able to see that truck, kind of the route, the trip timeline, and kind of where we're going on it, on the speed on those sides as they're looking through it. So being able to go through that information. So we did our method, we looked through, talked to a lot of folks, tried to make sure we got things set up a little bit, gathering all the data, working with everybody to make sure we're comfortable on what data is being collected and how we're collecting it, why we're collecting it. Those are really important things. That kind of helps with that buy-in and that feedback loop through it. And then once we have that, moving into our data analysis. So I'll start with the study and control routes and are looking at it. So this is the friction storm conditions and treatment. So we have the counties on the left-hand side, the dates the storm started. You can see those on it, the snow accumulation in inches, the pavement temperature for that, and you kind of see the range that happens with it. And then you can see the application rate, so that control route, and then our study route. So our control routes are salt, the pounds per lane mile, and then our study route is the brine, the gallons per lane mile, and then the application frequency and those minutes that went along with that. So you can see we ranged from 30 to 120 minutes on those application frequencies. When we thought about, so again, here is looking at those friction observations. So for our control route, we had 2,350. And then on our study route, we had about 2,800, 5 storms, 62 passes, Passes per storm varied between 4 to 28. The Marwis was on the treatment truck for Jefferson, and the data collection was during the storm for Jefferson County. For Sheboygan, since it was on the patrol vehicle, you can see that our friction observations are a little less. They're still very large. We're still thankful for that. We have 6 storms. We have 28 passes, between 2 and 9 passes per storm. The Marwis unit's on the patrol vehicle for this one. And then the data collection was 1 hour, starting right before the first treatment, and then moving forward from there. So each pass would have multiple friction measurements. We did a nested data structure. We tried to do the route type, the pass, and then the friction measurement to be able to look through that. We did a mixed effect approach. We wanted to do our fixed effects was the route type. And then our random effects were our pass and our friction measurements. And then we did a mixed effect meta regression modeling. Don't worry, I won't quiz you guys on any of this stuff, but just be able to see how we do this for repeatability. The heterogeneity of each pass is accounted for. We want to make sure we know that things are going to change, and so we want to be able to try to account for those as best as possible to compare for those. So this is the mixed effect meta regression modeling. I know there's a lot of information on here, but just to kind of cover it and looking at it, our kind of mean friction on the ith pass or whatever pass we're looking at there and examining it. We have our route type, whether it was our control or our study. So our salt, solid salt versus our brine route. And then we wanted to look at our route type. What was that effect of it? And being able to look at that, those random effects that we're looking at, and then the sampling error here. What we can see here is, and the kind of the table at the top there is that we have relatively small standard errors, which is really good to kind of show how this is looking at it. And then the p-values are low, so good works on that. So we think about our friction in our Jefferson County routes indicated a small statistically significant difference between the control and the study routes. On this side, I'm just going to move my screen for a second. So our red up kind of the top side here is our Jefferson routes. And then you can see on all of those. So you know, there's a small statistically significant, but when we look at kind of the practical side of it, it's a 3.7% difference. So, you know, okay, what does that really mean on that side? So there, and we didn't see a statistically significant difference between the friction of the control and the study routes in Sheboygan County. I know just from our own experience, when we started looking at and doing some of this work with brine, there was concerns about that the friction was going to be a lot worse with brine than solid salt because it was water on the roadway and it would freeze and it would have some issues with that. What we can see here and are looking at this through this modeling was that there was kind of no difference between those routes. So being able to look at those, and you can see that there's definitely some error bars and are looking at it kind of all over the place, but being able to kind of show this as we're going through. So the mean friction differences between the counties. So as you can see there, the Jefferson County was higher than the Sheboygan County. So we had between 0.4 and 0.8 for Jefferson County, and then Sheboygan was between 0.2 and 0.5. You know, where these kind of differences in the calibration. What we saw though is for each county though, it was consistent measurements, right? So we can do relative comparisons between the study and the control routes for each county, but maybe not kind of pulling them together just because there's differences in those mean friction differences between those two counties. So hopefully kind of that makes sense a little bit. One thing that we wanted to kind of look at a little bit more in depth was, you know, vehicle speed and travel disruption. We use the National Performance Management Research Dataset, NPMRDS, which is an acronym that I have a really hard time getting right most of the time. And this was to look at the kind of the travel disruption. This was you know, interesting for me and thinking about, you know, speed, right? Everybody does want to be able to travel at the speed that they were going with before the storm. But as we think about storms and how we actually do want people to, from at least from a safety aspect, travel slower and being able to look at those to make sure that people have enough time to stop and be aware of things of, you know, just the plows out there and things of that sort. So we kind of looked at this and wanted to examine it. So I'm going to go through the definitions that are on the left-hand side of your screen here and are looking at it. We have speed on the y-axis and time on the x-axis. that first kind of green line that kind of goes through, and I know that this isn't, this is just for demonstration purposes, but we have kind of our normal condition, our normal green sign. And then what we're going to see is with the storm start, we have a change of speed, right? So we're going to go lower in that speed as the storm kind of happens, and then it's going to go back up to our normal amount, right? It doesn't happen right away. A storm is going to start a little slowly. We're going to see the impact of it. So that second blue dot along that line of the normal condition is our storm impact start, T1. That's when we're going to start to see the reduction in speed a little bit. We're going to go down to that maximum speed reduction, which is that bottom of that yellow triangle, and then back up to the end of the storm. And as we know that the end of the storm happens, but then there's still things that happen that go along with it. Time to bear wet's going to be after that. And then the end of that, when we get back up to normal conditions, is going to be even farther away from that. So that's going to give us kind of our recovery time. So we have our reduction time to that maximum speed reduction, and then our recovery time. That reduction time plus that recovery time is our impact time total with that, and being able to look at it. So when we're thinking about our travel disruption, which is a kind of a new way to kind of think about this, and we're looking at it, what we're going to do is we're going to look at that maximum speed reduction. So the example here in pretty formats, right? So we have this, the storm impact is at 2 p.m. The storm impact end is at 6 p.m. here. We had a maximum speed reduction of 20, right? The impact time is 4 hours. And so then we're dividing that by 2 on this side and being able to look at that. So our travel disruption is 40 for this one. Be nice if it was always clear, beautiful lines like that, but as we look at our data, we're not going to be able to have that and examining it here. But we can kind of smooth it out and look at it here. So this is looking at Jefferson County, our studying control routes for 3 storms. This is looking at it here. We can see that those green line is our normal conditions again. So that's a historical average for that speed for those time periods, and are looking at it. So making sure that we're kind of examining it with that. And then you can see the yellow with those storms. You can see how the storm actually speed goes up for the beginning part of it and then drops back down. Here you can also see when those red lines are the truck kind of exiting with that area underneath that curve is our travel disruption with it. And then you can see our red dash line is that maximum speed reduction. You can kind of see how this kind of goes through this process. So we did those because we had a limited sample size. There could be no statistical tests done with it. We know that the study routes were similar or less than the control routes, which was good for us. So again, making sure that travel disruption isn't any different than our solid salt on it. Excuse me. And you can kind of see this process. So I won't go through each part of these tables, but it's our storm impact time, our maximum speed reduction, the ending on it, and then kind of that travel disruption between that study and those control routes down below for those 3. We had limited sample size for our time to bear wet, so there was no statistical test for that. You can see here that they are between our control and our study routes, they are similar as well. There's not any huge differences between our study and our control routes. So our control and study route limitations, we have no control data. This is kind of locations based on available friction data. Materials may include solid salt, and we're looking at it. As we think about being able to say whether we had those stations, as we think about those ARWA stations and looking at those, do they provide a numerical value of friction? Most provide just a categorical friction values, low, medium, and high, and some of those. So excuse me, sorry. All right. So as we move into the ARWA stations and looking at I-35 and US 10 that we talked about before, we're going to do some of the same type of work here. We're going to look at our baseline and then our speed and then when the treatment happened and then those friction values. So on A versus B here, so we have On the left-hand side, we're going to be looking at kind of those speed and friction values. On the right-hand side, we're looking at wind, air temperature, and precipitation, and being able to look at those. You can see when the treatments are done with those kind of light blue lines on the left-hand side. So kind of the same storm, same time period, just kind of different data sets and examining it. We did the same type of calculation for travel disruption and friction deficit as best as possible. So when friction decreased, the vehicle speed decreases. Good. Glad that that's happening for our roads. It's good for people to be able to be aware of that. I mean, where periods under a friction threshold served as measures of risk or safety. It's a very valuable information to monitor for mobility and safety performance as we move forward with this. So you can see our travel disruption and our friction deficit with those and being able to look at that. And then this is the hours with the friction less than, 0.8, 0.6, 0.4, and 0.2. We can, go back and forth about what is the right, friction value that we want to use for that deficit, but being able to look at those through that process. Here, these are our friction values here, so you can kind of see that baseline. This is starting at a little above 0.8, and then you can see it drop down. You can see when the treatments occurred, and you can see what's, again, nothing that's surprising for you guys to see, but when that treatment occurs, those friction values go back up, right? So we're able to see those jumps as we go through. So treatment's here, and those friction values go right back up. Treatment occurs here, those friction values go right back up. So interesting way to kind of look through this and being able to examine it on that treatment effect. So, yep, our ROS station data limitations, we have no control data, right? So it's just out there. We're not looking at those control and those study routes. The locations are based kind of available on those available friction data that's out there. We think that they're not exclusively salt brine deliquate applications. They may include some solid salt out there. We don't have it since it's not that specific control versus that study route like we have in those other characteristics. They may have a little bit of a mix, but it is able to give us some more information and being able to look at it. Stations located close to the bridges or ramps, so those also add a little bit more complexity to it in terms of our friction values. And then as you think about our ROS stations, some did not provide that numerical value, which I just showed you in that last screen. Some had a categorical friction values of low, medium, high. So we want to kind of look a little bit more carefully at those, and then some of those data quality concerns. So to our data analysis here and moving forward, I know I'm taking a lot of your guys' time here, so hopefully I'll be able to summarize this here and show those infographics and get some comments back for everybody here. So our study in our control routes that we looked at here in Jefferson and Sheboygan, they had statistically similar friction values. There was similar travel disruption, similar time to bare wets. The application rates, as you would expect with salt brine, that use 40 to 72% less salt with that salt brine. So the big key point here is that the salt brine direct liquid application and solid salt have similar performances while using less salt, which is better for the environment, and the benefit cost is better as well for that. The ROS stations had travel disruption and friction deficits that we were able to. This kind of contributes to assessing weather impacts and treatments. It's helpful to Stardust to get to be able to think about those operational and those safety thresholds as we're thinking about performance metrics and things to move forward with it. So our final deliverables. This is one of our final deliverables, this webinar, which I've been coughing through. I apologize for that. We have a final report documenting the entire research effort. I'm gonna show the infographics that we kind of looked at, summarizing those key findings, and then all final deliverables will be available on the Clear Roads project website that is available there on 22-04. So, as we looked at our infographic, this was the first one we put together, and got comments back that it was helpful, but very wordy and not able to be given to the general public and being able to look at it, right? So we had a pretty picture and looking at the Clear Roads project, those weather conditions, what those study and control routes were, those kind of frequency and application rates, what's going on with it, pavement friction, and kind of what we looked at for our performance measures with it. So kind of summarizing that, the amount of salt, 24% reduction in time to bare wet, 15% reduction in pavement, from previous studies and 8%. So it kind of covers the previous and then what our projects are on this side. So being able to kind of start with that one. And then we went through and tried to do it and make it a little bit easier to kind of grab and look at. So this is kind of our comments for our second one, and would love to hear from folks on this one as well too, is that really highlighting the amount of salt is less, 40 to 72% less, and everything else is very similar with it. And then giving some information about the project report on the right hand side. What were those application rates? What were those? How do we do the pavement friction? How do we look at that? How do we gather the vehicle speed, the time to bear wet, and being able to look at that? So trying to think about from this one that had a little bit more information kind of tucked in there, trying to kind of make it a little bit simpler and moving forward on this infographic on the second one. So, and there's our contact information. So I'm going to leave it on this infographic. I'm going to go ahead and see if there are, Greg, I can turn it over to you and see if there's any questions that are coming in or any comments.
All right, thanks, Andy, appreciate it. All right, this would be the time to open it up to anybody who's got any thoughts on any part of the presentation or the infographic. Oh, we went away from the infographic. There you go. Cool.
Sorry, I wanted to be able to see your guys' see the comments is going through.
I know. Yeah. Patty Caswell has a question.
Thank you. Yeah, I had a question on the graph that showed the basically the test results on the speed and the storm. The truck exit, what I'm not sure what that means. That just means when the truck left the road and stopped applying, or those red dots on the graph?
These?
Yeah.
Yeah. Boris, do you want to jump in and explain what you mean, kind of that specific definition of truck exit, just kind of being there, going through?
Yes. The truck exit basically means when the truck ended applying material on the routes, basically. Yes.
Okay. Thank you.
Craig Bartfried from Iowa has asked the question, do you have an infographic that uses the data from the Iowa DOT instead of the Wisconsin DOT?
So, Boris, you want to talk a little bit about that for me?
The infographic was basically the first one was a summary of all the data that we had from previous projects and the current project, right? So we wanted to condense all the information that we actually have, gathered from different projects that we have conducted in this new project. And the infographic 2 is basically just summarizing the overall results. I know that we don't mention the ARWIS results in these infographics. We felt that it was difficult to convey some of the findings from the ARWIS stations, and we just basically provided the data that was available from the controlling study routes.
And part of that too is just because we weren't exactly sure what else was being put down on those routes on those exact times, Boris, right? That we didn't want to confuse anything because of possible some data quality issues or us not understanding that data quality, correct?
Yeah, that's correct, because on the ARWIS locations, it wasn't direct liquid application. It was other treatments, including pre-wet material, yes. Since the project specifically focuses on direct liquid application, that's why we emphasize on the infographics, that particular study control analysis.
We think that the work that we did with the ROS stations are helpful for the future, but just in terms of being able to fully compare direct liquid application to solid, it was harder to do in the infographic.
So other questions or even from the project subcommittee, do you guys have any thoughts on this second version of the infographic? Yeah, Mike, we'll go ahead and get this posted by the end of the week or early next week. So, so I'll jump in a little bit here, I guess. So just looking at this version of the infographic, so tell me again, who's the intended audience of this particular one that we're seeing on the screen right now?
So a little bit of both, right? So we're thinking that, you could use the left-hand side for general public, right? And being able to look at it on that side, but then being able to have that information about what's being looked at on the right-hand side. So almost like you could kind of fold it back and being able to be there. People have questions, but being able to kind of look at it on that side.
Mm-hmm. Yeah, the way my just first thought in looking at it is almost exactly what you were saying. The left side would be very valuable for the public. The right side, they're going to get lost probably. I mean, with some of the terminology and all the things that kind of go into it. But I think that this would be, handy for some of the other things that we're doing, that Clear Roads is doing, such as the public service announcement library, where we're creating content for states to use to, especially their public information officers, to put out through social media blasts and things like that. And the module we're currently working on is liquids. So I'm thinking that the left side of that infographic might be really valuable for that particular effort. Does anybody else, again, specific? Well, it could be anybody in Clear Roads, but just I'm thinking of the project subcommittee that's been involved with this and took a look at the first infographic and had comments about it. Do any of you guys have thoughts on this second one?
Yeah, this is Emil. Yeah, I think thank you for creating this second one, Andy. I think this basically is what I was asking for, just to the point of, for the public specifically. So just basically the what is the result? I mean, what is the comparison, right? And that's what they needed to do. And again, if they want to refer to, if anyone is interested in referring to what the sources of these data, and then, like you said, the left-hand side, you can just basically just cut out and then just post it at a separately. And then, something like, if we're thinking social media, then the right-hand side can be, the caption or whatever it is. So I think I like this. Yep. And the first one is actually really good too, as someone, as a couple of people already responded in the project committee, and that is like a very, very like what do you call it, all-inclusive summary of everything that's in the study. So that was good too. But again, it's too busy for public consumption, and this is a lot more straightforward. So I like that. Thanks.
Glad you like it. Thank you.
Greg, this is Paul. I'd like the second one as well. I don't think it's quite as busy as the first infographic. I agree with comments like Emil was saying, that you can give the public the information there on the left. I want to be able to use this exact type of information internally. And we're trying to promote more direct liquid application in our state. We use brine quite a bit for pre-wetting and wetting our salt, but we don't do a lot of direct liquid application during a fight. So that's one thing that we're trying to push towards. I did have another question, Andy, on cycle times for trucks that were doing direct liquid application. Can they not travel as far as a salt truck before they have to come back to the shed and fill up again? How many miles can they travel versus a salt truck on lanes treated before they have to come back and fill back up?
Great question. Boris, I know I'm going to put you back on the spot. Do you remember from our previous study when we looked at some of those capacity on that? I know you did the benefit cost, so I don't know if we know from this study, but from our previous studies, you might have some information.
Yeah, well, from this study, basically, Jefferson County in Sheboygan County were very helpful in the process by basically modifying some of the routing for the purpose of the data collection. So basically, they were close by to one of their shops. So they were able to consistently, as soon as they left the shop, they will be able to treat the route. So more or less, that was the setup that we had. And yeah, usually, for instance, Jefferson County has a 50-minute to 60-minute interval routing for their particular trucks. In terms of Sheboygan, I'm not that familiar. Usually, they just modify their routing for the project. But yeah, in general, Jefferson County has a 50-minute cycle for their trucks that are equipped with both salt and salt brine.
All right. Paul, does that at least sort of answer your question?
I think Paul, you were getting at just in general, right? So what is the capacity for cycle times for a brine truck compared to a salt truck?
Yeah, and maybe miles might be more intuitive to me than time. I mean, how
Okay.
many miles was a brine truck able to treat versus how many miles is one salt truck able to treat?
Yeah. Thanks, Paul. We can take a look at that. I don't think we have that readily
And
at our
Paul,
fingertips.
yeah, that project that we did on plow cycle times, does that offer any assistance?
Just a quick
I'd have to
comment
go
on
back and look at
that
it.
is that it's going to all depend on how much material the truck can haul, how many gallons, how many pounds of salt, and what the application rate is, and you just do the math on that, and it'll give you the distance.
Jim, you got a question?
Well, I was just going to speak on, I kind of agree with Paul. A lot of this information is going to be great for when I go out to do brine training with our folks. So I really like it from that. But that second page I thought looked a lot better for the public. We do put some information out already of why we use salt brine over straight salt. And when it comes to making those guesses on using straight brine or salt for distances, the big thing you got to factor in there is your speed, because when you got the salt brine, you can go faster shooting that. So it does take up a little less time in turnarounds. What we typically try to get our folks to do is for turnaround times is to go behind those direct liquid applicators and follow up with 50 pounds of salt. That gives them more of a turnaround time so they can get back and get their liquid filled up, because you do have a lot less miles you can do with a direct liquid applicator.
Okay, Ty's got a question.
Yeah, I was just going to make a comment to that. We do have some data in Idaho on that fact, but I think our liquid trucks, can only go about half as far as our salt trucks, salt rate, equally the distance. So it's taken our liquid trucks about double the time as our salt trucks, with reloading times. But I can maybe help provide some data in the future.
And Wilf chimed in. Wilf, do you want to just, rather than me read the whole thing, you want to go over?
Sure. Yeah, it's really just a function of the capacity, as others have said. If I can carry 1,000 gallons of brine capacity, I can treat 20 lane miles before I refill. Whereas if I have 5-ton capacity of solid salt, I can do 50 lane miles at the rates of application we were talking about here. If I'm going with something that is very much optimized for liquid application, I might have some sort of tanker truck, and that might give me 5,000 gallons of brine, which would go up to 100 lane miles. But people may not feel comfortable about using tanker trucks during storms. So, it's what's your equipment mix? And sorry, didn't mean to be Captain Obvious on that one, but.
Okay. Anybody else?
Hey, Greg, it's Joe Thompson. Joe T.
Yeah.
The two sections that were in the data collection, I think one was 3 miles and the other one was 3.3. But I think there'd be some value in just having that be part of what was on the one pager, so people realize that's not the entire beat. Not that that's necessarily makes a difference, but it's that was the control, that was the, or maybe it would add confusion. I don't know, but that was just something that jumped out at me.
Thanks, Joe. And on that right-hand side, we kind of talk about those routes. We can put them in parentheses, what those miles were between that and Jefferson and Sheboygan. Thank you.
All right, well, this project is wrapping up this month, the end of this month, so another 3 weeks. So just as a reminder, I guess, we're at the beginning of this, well, no, I guess we're right smack dab in the middle of this week. So I just encourage the research project subcommittee, any final comments you have on either of the two. And Andy, could you send me that second draft so I can post it on the members page?
Yes. Can you do that?
Okay, thanks.
Okay.
So yeah, any final comments you guys want to have on either of those two infographics once I get that second one posted? Also the draft final report, if there's any feedback on that. And then that way we can go ahead and get these approved and those approvals sent over to the state of Minnesota. And Andy, if you could also send me the PowerPoint for this one, we like to post that on the members page as well for our members to use for any presentations they want to do in-house. We'll have that available for folks. But otherwise, I think, I think everything's been covered here. Currently, CTC is drafting the research brief for this project, and that'll be also posted on the project page when it's available, as well as both the final report and the infographics will all be posted on the project page, as well as this webinar. So thank you everybody for joining us today. Appreciate your time. Enjoy the rest of your snowy, icy weeks. Be safe out there, and we will talk to you soon.